This is an A-level core pure question on improper integrals. Show that this integral between the limits of 0 and infinity of 8x minus 12 over 2x squared plus 3 times by x plus 1 integrated with respect to x is equal to log k, where k is a rational number to be found. Now this is a partial fraction. But this is a partial fraction where we've got this x squared or 2x squared in here, and there's a way that we need to deal with that which is slightly different to what you would do in normal maths, and that is that we need to write this as ax plus b over this denominator of 2x squared plus 3 plus c over x plus 1. So you don't just write a over 2x squared plus 3, it must be axb over that denominator. So we're going to write it in that form, and that's going to allow us to change it to partial fractions. And then once we've done that, then we'll sort of think about the improper integral, that limit. Okay, so let's say we want to do this 8x minus 12 all over 2x squared plus 3 all times by x plus 1. And that's dx. So we'll take this, just the algebraic part, and then we'll use partial fractions there. So we'll say that ax minus 12 over 2x squared plus 3 times by x plus 1 is equivalent to ax plus b over 2x squared plus 3 plus c over x plus 1. So we want to make the denominators the same on both sides, which means multiplying this first fraction here, the top and the bottom, by x plus 1. So let's see if I can get it on this line here. So you've got ax plus b times by x plus 1. And then the second fraction, we want to multiply that by 2x squared plus 3. So c times by 2x squared plus 3. And then now that can all be written over one denominator, which is going to be the same as this denominator here. So 2x squared plus 3 times by x plus 1. Now that the denominators are the same, we can equate the numerators. So equating the numerators is going to give us 8x minus 12 is equal to ax plus b times by x plus 1 plus c times by 2x squared plus 3. Now I could multiply all of the brackets, but what I'm going to do is try and do that bit in my head, because I'm going to use equating coefficients to help me work out the values of a, b and c. So let's start with, let's say, the x squared term and equate the x squared terms. Now on the left hand side, the coefficient of the x squared term is 0. So I can make 0 equal to, now what am I going to have in front of x squared on this side? Well, from here, when I expand this bracket, I'll have a, and from this bracket I will have 2c in front of x squared. So I've got the a plus 2c is equal to 0. Okay, so we'll hold on to that for a moment. That's one equation. So now what I'm going to do, I'm going to equate the x terms on both sides. So if I equate the x terms on the left hand side, the coefficient is 8. And then on the right hand side, let's see what we get when we expand the brackets. So I will get ax plus bx. So in front of the x from this term, I'll have a plus b. But here I won't have anything in front of the x term. So it's just going to be 8 is equal to a plus b. Okay, so there's another equation. Let's now equate the number terms, or the constant. So let's put constant. So if I equate the constant, then on the left hand side I have negative 12, and then on the other side, let's have a look. So I will get a B, 1B, and then I will get a 3C. So B plus 3C. B plus 3C. Okay, so that's going to be my third equation to solve. Okay, now I guess I could solve these manually, but you know, it's straightforward enough just to use the calculator to solve it. And if I solve it using the calculator, I get A is equal to 8, I get B is equal to 0, and I get C is equal to negative 4. Now I think on the mark scheme, all of this is just worth 1 mark, so you could just do this on your calculator and find the solutions. So now I can rewrite the integral as these partial fractions. So the limits are still 0 and infinity. So I'm now going to write this as this in this form. Okay, so I've got A is 8, B is 0. So basically I'll get 8x over 2x squared plus 3. Okay, because B is 0. And then since C is negative 4, it's going to be minus 4 over x plus 1. So this is now the integration that I need to do. Now for both of these are of the type where we have an integration where basically the numerator is a bit like the denominator differentiated. There's a constant we need to sort out. We'll do that in a moment. And when we get a question like that, then the answer is just going to be log of the bottom, and we'll have this constant here, k. So let's sort out the constant and make it fit the pattern. So I know that if I differentiate the bottom here, I will get 4x. Okay, so what I'm going to do is to put a 4 at the top to make it fit the pattern. So we'll cross that 8 out and we'll put a 4 here. But you can't just change the question, so I'm going to put a 2 here. And now it fits the pattern, it's just going to have a 2 in front. Now this one, when you differentiate the bottom, you're just going to get 1 at the top. So I'll put a 1 at the top to make it fit the pattern. And then I can't just change it. I'm going to put the 4 now in front of the fraction to keep it all balanced. So now I can just apply the rule. And when I do that, we will have basically 2 times the log of the bottom here. So that will be 2 natural log 2x squared plus 3, and then minus 4 the log of the bottom, and that's going to be x plus 1. So at the moment we've still got these limits of 0 and infinity. So what we'll do now is we'll just tidy this up a bit, put those logs together. So because it's a subtraction, it's now going to be a division. So log of, and then it'll be the 2x squared plus 3, and that's going to be all squared because I'm just bringing that power up here, and then divided by, and then it'll be this to the power 4, x plus 1 to the power 4. I don't need the modular symbols anymore because these are going to be positive anyway. And it's this that I'm going to do between the limits of 0 and infinity. But at this point we say, right, we now want to work out the limit as t approaches infinity, and this is where we make this substitution with t. So I'll now write that out again, but my upper limit now is going to be infinity now, and not t and not infinity. So let's write this out again. So over x plus 1 to the power 4, and with this limit now of t here and 0 at the bottom. We'll put that t in, so we'll have log of 2t squared plus 3, that's all squared, over t plus 1 all to the power 4 minus the log of, well, we're basically going to be putting 0 in here, so 2 times 0 squared, which is 0 plus 3, so it's just 3 squared at the top, so I'll get 9. And then at the bottom, when I put 0 into here, it'll just be 0 plus 1, 1 to the power 4 is 1, so log 9 over 1, which I could also write as just log 9. So I'm doing some in my head here, but hopefully you can follow my working. Now, this is going to be the bit here we need to evaluate. So I'm going to do something which I guess, I don't know whether you're allowed to do it or not, but we're going to try and think of infinity as a number. So that's why I'm going to do it up here. This is just going to help me work out what this is. So what I'm going to do is actually replace the t's with infinity. Think of it like a letter or something, and see what happens if I try and simplify it. So think of it as 2 infinity squared plus 3 all squared over infinity plus 1 to the power 4. Now, if we want to simplify this, the first thing we need to do is to think about, okay, if we've got infinity, do these numbers here really make any difference? No. So let's get rid of them. Adding 3 to infinity is so small we can forget about it, and adding 1 to infinity, again, we can forget about it. So those numbers have now gone. So what we're now left with is 2 infinity squared, and that's all squared. And at the bottom, we've basically got infinity to the power 4. And if we continue with this process, if you've got 2 infinity squared all to the power 4, then you could think of this, basically if you square it, as 4 infinity to the power 4. So at the top, let's write 4 infinity to the power 4, because we've just squared it. And then at the bottom, we've just got infinity to the power 4. And then what's going to happen to this? Well, you could say, well, basically these infinity to the power 4s cancel out, don't they? Because it's basically the same thing. Okay, I guess mathematically you wouldn't really think of it this way because infinity is not a number, but it does help you simplify things like this. So basically all you're left with is log 4, the limit as t approaches infinity. If we follow it through, all of this just becomes log 4. So now we've got log 4, so this is still the limit as t approaches infinity, log 4 minus log 9, which we can write as log of 4 over 9. Now we needed to write it in the form log k, which we've done, and basically what we've got is the value of k is equal to 4 over 9. So let's just highlight that. That would be our final answer for this question.